Welcome back to the classroom. My name is Mr. Wong. Today we're going to be looking at the 2018 Independent Physics paper. It is question 22, and the question is going to be asking us to analyze motion time graphs, as you can see here, speed over time. This is going to look into Module 1 Inquiry Question 1. So let's have a look what the question's asking us to look at when it comes to this graph. So question A, it says describe the motion of the object. Well, you can see from the time of 0 to 20, it's traveling at a constant speed of 6. From 20 to 30 seconds, it is accelerating. So it's increasing speed from 6 to 8 meters per second. We can also do a calculation on acceleration because we know that the gradient of this line here is acceleration because we're trying to find the change in speed over the change in time. And we can also see there is some kind of deceleration here. So there are a couple of things we can look at. Okay, so what we can say is at 0 to 20 seconds, the object is traveling at a speed of 6 meters. Object travels at 6 meters per second. At the time of 20 seconds to 30 seconds, the object accelerates. And let's just quickly work out what that value is. So 8 minus 6 over 10. So 0.2 meters per second squared. So we do 8 minus 6 over 10. And then at time 30 seconds to 50 seconds, the object decelerates at the value we have here. Let's see, that's 25, 15 seconds have passed. So at negative 0.53 meters per second squared. So that covers that one. And we go to the last one. It says sketch a displacement time graph for the first 30 seconds of motion. So we need to firstly work out the displacement, this part here, and also this part of the displacement here. So let's quickly have a look at the overall displacement gone. So remember, the change in displacement is the velocity times the change in time, or the speed change in time. In this case, the speed is 6. The time that's passed is 20. So we've covered 120 meters in the first 20 seconds. And then we can calculate this part here. So what we have is in 10 seconds, we have, or we can try and break this up into calculating the area of this particular shape here. So it'd be 10 times 6 plus, in this case here, 2 in the height. So 2 times 10 times a half, because we have a triangle here. And so the total distance traveled in that second part was 70 meters. So we have 120 in the first 20 seconds, and then at the end point of 30 seconds, we traveled a total of 190 meters. So let's try and draw that out as a displacement time graph. So we have displacement over here, S in meters. We have time in seconds. We can start off at 0 here. We then go to 20 seconds. Because the object is traveling at a constant speed, we expect that it is a linear increase up until 20. So about so there. So that's 120 there. And then afterwards, from that to the 30 seconds here, the object is accelerating, so we can expect that the line begins to curve up. So straight line, and now it begins to curve up like so to about 190 meters. So that's what we can see happening here. Alright, so that's how you analyze motion time graphs. If you found this video useful, give it a like, subscribe, and I'll see you next time.